Welcome to Maths with EJD. In this video, I'll be talking about network metrics. In the previous one, I talked about types of networks, talking about social networks, communication networks, and transportation networks. So here, let's look at some metrics that are used in network analysis. First of all, we know that, okay, what are metrics, right? What are metrics? Metrics. Okay. They are simply tools used to analyze networks, helping us understand their structure and identify keynotes or patterns. So there are we consider three essential metrics. Okay, the first one will be degree distribution. Degree distribution. In graph theory, we already looked at the idea of degrees, which is simply the number of edges that get into a node or get out, and all the edges that get into and out of a node. So we have degree distribution. We have here clustering coefficient, and then we have centrality. Okay, so let's take them one after the other as we unpack them. So first, let's talk about degree distribution. Okay, the distribution of the number of connections. Degree distribution is the distribution of the number of connections or edges each node has, each node has in a network. Okay. So the degree distribution is the distribution of the number of connections or edges each node has in a network. For example, for example, if you look at social networks, right? Social networks. So on X, right? Former Twitter, on X, which is former Twitter, degree distribution, degree distribution shows degree distribution will show us degree distribution shows that most users have few followers. Most users have few followers, but a small number have many. A small number of users have many followers, forming a long tail. So forming a long tail. So the idea of long tail is well explained in my statistics playlist. I want to check that out. I have like 35 videos talking about that under the measures of distribute measures of shape, I believe. So that's for social networks. What about for transportation networks? What can we say about degree distribution and transportation networks? So here, right, transportation network shows the number of routes, the number of routes, the number of routes, right, converging at stations, converging at stations. So we actually have a few key hubs. We have a high degree. A few key hubs may have a high degree. For instance, if you want to compare stations in Tokyo, Osaka with maybe more interior places like maybe not really interior like Sendai, they are totally different because you have more routes leading to stations in Tokyo than maybe a place like Sendai. So that is degree distribution. It's simply the distribution of the number of connections or edges each node has in a network. So I think it's bear close resemblance to degree in graph theory. So let's go on to talk about clustering coefficient. Clustering coefficient. So here, clustering coefficient actually measures how likely a node's neighbors, how likely a node's neighbors are to connect with each other, to connect with each other. So let's look at examples of this. I mean, this is something like what are the possibilities that people I have as friends are actually friends with themselves. That's the idea here. So let's see for social networks, right? Social networks. So high clustering occurs in tightly knit, tightly knit groups, in tightly knit groups where friends are likely to know each other. Friends are likely to know each other. For instance, on my social media platforms, most of my friends are actually from the schools I've ever attended. So there's a high likelihood that they are also friends with themselves because um, I have many people that we actually attended the same schools. So let's look at the case of transportation networks. It's talking about clustering coefficients, transportation networks. So in transportation network, clustering coefficients indicates how interconnected, how interconnected a set of stations, a set of stations is through direct routes, forming efficient subnetworks, forming, forming efficient subnetworks. Okay, that's now about clustering coefficient. Now let's go for centrality. Centrality. So these are measures by which we measure networks, right? So centrality identifies, it identifies important nodes. Centrality identifies important nodes in the network. So common types of centrality, we have different types of centrality. Common types include what we call degree centrality, for instance. Degree centrality. So for degree centrality, it means that the number of edges, the degree centrality is the number of edges connected to a node. Okay. Then a very good example of this would be um very good example of this would be that a well-connected server, a well-connected server in a communication network, in a communication network, or a busy train station, a busy train station in a subway system. In social networks, right, that would actually be maybe people that are called influencers. They have a lot of followers, a lot of connections. So that's degree centrality, right? Let's talk about closeness centrality. Closeness. Okay, I guess I want to change markers at this point. Just change altogether. Say I go this. So closeness centrality. Closeness centrality. So here, closeness centrality measures, it actually measures how close a node is to all other nodes. How close a node is to all other nodes. Okay. Then an example of that would be a central subway station. A central subway station that minimizes travel time to all other stations. So, I mean, town planning would take this into consideration. For instance, I'm currently in Sendai in Japan, and we have a central station called Sendai Station. So if you are lost anywhere in the city, just go to Sendai Station. You can find your bearing because it's very central, and from there you can go to every other place very easily. So that's the idea of closeness centrality. Okay. Or, I mean, still, if you want to look at it of in the context of social media, right? If you want to, most of the times, right? If you're probably you're looking for some kind of connections. Maybe you need somebody to help you do something. In fact, a practical example happened today on Facebook. Someone who is very influential on Facebook just put out an information that she needed a professional CV writer. And before you knew it, like within 1 minute, 2 minutes, a lot of people already were suggesting that, oh, okay, this person, I mean, a particular person was even dominating the tagging, right? So influencers like that can actually provide a kind of, means by which you can easily get across to uh, what they call plugs, right? Like maybe you need somebody to help you fix something or somebody to supply you something like that. Okay, so that's about closeness centrality. Then we also have the betweenness centrality. Betweenness centrality. All these are under centrality. So we have the betweenness centrality. So betweenness centrality actually measures how often a node acts as a bridge. How often a node acts as a bridge between other nodes. Okay. A very good example of this will be, okay, I think it's the kind of example I've been giving a lot. So a user, social media user who connects, who connects two separate groups, two separate groups of friends. So there's a likelihood, right, that, maybe there's a particular, maybe you and your friends that you have not even seen in a long time, you share some kind of common interest, and then there's a particular social media user that is an icon of that thing. So it's possible. I mean, many times I go on a very popular person's page or a very popular group's page, and I see some of my friends have liked things there before. That can even be an opportunity for me to connect with them. So a social media user who connects two separate groups of friends, or an airport an airport that connects multiple multiple international routes. Okay, that is betweenness centrality. In summary, in summary, we see that metrics like degree distribution, degree distribution, clustering coefficient, and centrality offer valuable insights into network behavior, into network behavior, helping us optimize design and functionality in social, transport, and communication systems, right? So that's what we have. All right. So this still continues. I'll be talking about more things under network theory going forward. So make sure to subscribe to the channel, hit the notification bell so you can always get alerted each time a new video is released. Comment. Let me know if you want me to solve a problem or teach a topic. Then like and share so that more people can have access to this great content. Till I come your way again, keep networking. Bye.